Have you ever looked at one of those giant AI models and thought, man, I wish I could teach it a really specific new skill, but figured you'd need like a supercomputer to do it? Well, it turns out there's a brilliant technique that makes it possible for pretty much anyone. And today, we are going to dive into exactly how it all works. But before we get to the solution, let's really get on the same page about the problem. Why is it so incredibly difficult and so expensive to customize these massive AI models? For most developers and creators, this isn't just a small hurdle, it's a brick wall. It stops so many amazing ideas right in their tracks. So here's our game plan. We're going to tackle that dilemma head on. Then we'll introduce the solution, LoRA. We'll break down all of its key advantages, show you how to actually put it into practice, and then finally walk through the whole process, all the way from training to deployment. All right, let's get right into it, the dilemma. At its core, the problem is just the insane cost of customization. We have these super powerful base models, right? But the process of making them uniquely yours, well, that's been a massive, massive undertaking. Just think about it for a second. When you fine-tune a model the old way, you're trying to adjust billions of different parameters. The amount of GPU power and memory you need is just staggering. It basically puts a members-only sign on cutting-edge AI, locking out anyone who doesn't have access to a huge tech company's hardware budget. So how do we get around this? Well, this is where LoRA comes in, and it is such a clever and efficient technique. It really blows the doors wide open on fine-tuning for just about everyone. Okay, so here's the magic trick behind it all. LoRA, which stands for low-rank adaptation, it doesn't retrain the whole model. No way. Instead, it freezes all of those billions of original weights and then injects these tiny little trainable modules into the model's layers. You want an analogy? Imagine the base model is a giant printed textbook. Instead of rewriting entire chapters, you're just adding small, editable sticky notes. You only train the sticky notes, not the whole book. It's that simple. And this comparison just makes it crystal clear. On one side, you've got full fine-tuning. You're changing everything, the whole shebang. But on the other side with LoRA, that massive base model is frozen, completely untouched. You're only training a tiny, tiny fraction of new parameters. And that right there is the secret to its incredible efficiency. And this efficiency, this is exactly why LoRA is such a breakthrough. You get all these amazing resource savings, but usually without any real drop in quality for whatever task you're fine-tuning for. It's truly the best of both worlds. So let's just run through these benefits, because they're huge. The first three are all about making this stuff accessible. By slashing the number of trainable parameters, you save a ton of memory. And that's what finally lets you do this on a regular consumer GPU at home. And the last two? They're all about performance and just making your life easier. You get no extra lag when you run the model, and managing these little adapter files is an absolute breeze. It's a win-win all around. Okay, so let's put some numbers on this. We're not talking about a small improvement here. On a typical model, LoRA can reduce the number of parameters you have to train by around 90%. Just let that sink in for a second. Instead of training, say, 100 million parameters, you're only training 10 million. That is a total game changer. But it gets even more dramatic when you look at the truly giant models. Take GPT-3 with its 175 billion parameters. Fine-tuning that normally is it's unthinkable for an individual. But with LoRA, it reduces the number of trainable parameters by a factor of 10,000. No, that's not a typo. 10,000 times fewer. It literally takes the problem from impossible to, hey, let's try it this afternoon. That kind of efficiency is just mind-boggling. So what does a 10,000x reduction actually mean for you and your computer? Well, it means you need 3 times less GPU memory. And that right there, that is the key. That's what unlocks the door, letting you fine-tune these massive models on hardware you might already have, instead of needing access to some giant server farm. Okay, so you're sold. LoRA is powerful, it's efficient, but how do you actually use it? Let's get practical and look at the super simple workflow for putting this thing into action. So, thanks to some incredible open source libraries like PFT and TRL from the folks at Hugging Face, the whole process really just boils down to 3 main steps. First, you define your LoRA configuration. Second, you set up the trainer. And third, you just hit go and start training. These tools do all the heavy lifting for you. Now, when you're setting up that config file, these are the parameters you're going to care about the most. R, or rank, that's the big one. It controls the size of your sticky notes. A higher rank means a more powerful but bigger adapter. LoRa alpha is just a scaling factor that works with rank. Dropout is a nifty little trick to keep the model from just memorizing your training data. And target modules lets you pick exactly which parts of the AI's brain you want to add your sticky notes to.
And hey, here's a quick pro tip for when you get started. Don't go crazy with the rank right away. Start small with a value like 4 or 8. It'll train way faster and use less memory. You can always bump it up later as you experiment and find that perfect sweet spot between performance and efficiency for your project.
All right, you've done it. You trained your model, you've created your very own LoRa adapter. So what's the last step? Let's talk about crossing the finish line, getting your new specialized model ready to go out into the real world. So once training's done, you've got a choice. You can merge your small adapter weights right back into the original base model. This basically bakes in your changes, and it creates one single unified model that's super easy to deploy. And the best part, there is absolutely zero extra lag or slowdown when you run it. Now, if you do decide to merge, here are a few key things to keep in mind for a smooth ride. First, make sure you have enough memory, because for a brief moment, you're holding both the big model and the adapter. Use automatic device mapping to let the library figure out how to use your hardware best. And finally, and this is a big one, do not forget to save the tokenizer. That's the model's vocabulary. Without it, your new, smarter model won't know how to understand words. But here's the really cool part. You don't have to merge. This is what makes the whole system so flexible. Using a library like PEFT, you can keep your adapters as separate little files. This means you can load the same base model and then swap in different adapters on the fly. Maybe one for summarizing articles, another for writing Python code, and a third for writing poetry. It makes experimenting incredibly fast and efficient. So there you have it. LoRa is a powerful, accessible, and just plain brilliant technique for customizing these giant AI models. It's democratizing fine-tuning, putting world-class AI development into the hands of way more people than ever before. So the only question left is, now that you know the secret, what amazing thing are you going to build first?